I am a tutor of mathematics. My intention this afternoon, or wherever you are, depending on the time, this moment, my intention is to treat indices and exponential equation with you. So if you are probably coming across my page for the very first time, kindly watch, like, share, and also follow. So in this class, we'll be treating indices. And firstly, I'll be putting in consideration laws of indices and how to go about questions of indices, obeying different laws that they look like. All right, so when you are talking of indices, you're talking of numbers that are raised to powers, numbers that are in power form, something like 6 to the power of 3, something like 6 to the power of 3. So that's what you're talking of. So then when you have different operations on them, 6 to the power of 3 times 6 to the power of 4, what do you do to it? When you have something of 4 raised to the power half, what do you do to it? When you have something like 6 raised to the power negative half, what do you do to it? So things like this, whenever you are operating, you're working with numbers with powers. So that's when you talk about indices. So you're talking about exponents, numbers with powers. So indices, I'll start with the laws of indices. Laws of indices. So before the laws of indices, when you have a number such as 7 raised to the power 5, the 5 here is the power. The 5 is the power. So I will start with multiplication law of numbers with the same power. So that's when you have a raised to the power x times a raised to the power y. So this very law, or this very law, is what I'm starting with. So when you have something like this, you see that the numbers, the base are the same. That's a to the power of x. You also still have a to the power of y. So since the base are the same, whenever the base are the same, this is what you do. You pick one of the bases, which is a. Since they are similar, you pick one. So the powers, that's x. The multiplication here will turn to addition, and this is what you do when you have this kind of question. When you have question in this form, this is what you will have. So this is the multiplication of numbers with the same basis but different parts. Okay, so if you also have it in this form, a to the power of x divided by a to the power of y, and in this case you have the same base but different power. So for this case, you pick one of the bases, then you have x, the division will turn negative, that's minus y. So this is what you do in case 2. So this is the division of numbers with the same base but different powers. So that's what you do with them when you have such questions. That's what you do. That's what you do. All right, so that will take us to another law that says a to the power of 1 is just the same as a. A raised to the power 1 is just a. Meaning any number raised to the power of 1 is that number. Alright, another one is a to the power of 0, which is called 0 power. 0 power law. This one says that any number greater than 0, any number that is not 0, rather, any number that is not the same thing as 0, that is raised to the power of 0 is always 1. Any number that is not the same as 0, but is always raised to the power 0 is always 1. So this is what I mean by that. If you have something like 5 raised to the power 0, the answer is just 1. 5 raised to the power 0, the answer is just 1. If you have something like 3 million raised to the power 0, the answer is just 1. No matter how big or small the number is, as long as it's raised to the power 0, it is 1. But then, if you have 0 raised to the power 0, 0 raised to the power 0 is not 1. It's not 1. So that's what the statement is saying. That any number raised to the power 0 is 1, apart from 0 itself. 0 raised to the power 0 isn't 1. So this is another law. So this is, let me call this the first law. Let me take this as the second one. Let me take this as third law. They may not be, some of them may not be like, I don't know how to put it now. They may not be identical law. They may not be the definite law. Some of them may not be a definite law. They may not be, I'm looking for the best word to describe it with. They may not be a typical law of indices, but they are not, there are things that you should know about indices. Alright, so we have considered about 4 of them. So another law is, let me name this as law 5. Alright, so let me give you some techniques in order to remember this particular law, because it's very essential you have tricks that you use in remembering. Alright, so when you look at this very first one, what happens is, this third one, what happens is you have a number that has a particular power multiplied with that same number with a different power. So multiplication actually yields positive results in most cases. When you add numbers together, you see them coming up. Unlike when you subtract a number from the other, when it comes down. So here, when you multiply this and this, your answer should give you something positive. Okay, let's see, something greater rather. So let's say we have 3 raised to power 4 times 3 raised to power 2. 3 raised to power 4 times 3 raised to power 2. This should yield a bigger answer. That's something 3 raised to power 4 plus 2. That's 3 raised to power 6. The answer would be bigger. The answer here would be bigger than the very first one. But if it were to be negative case, division case, that's 3 raised to power 4 divided by 3 raised to power 2, it will be 3 raised to power 4 minus 2. Are you following? So 3 raised to power 4 minus 2. And in that case, your answer will now be 3 raised to power 2. So compare this 3 raised to power 2 to 3 raised to power 4. You realize that it gets smaller. The answer gets smaller when you are dealing with division. And when you are dealing with multiplication, it gets bigger. So that's my point. So the first thing you try to remember is, as long as they have the same base, you are picking one of the base, then when it's multiplication, the powers, you sum them up. If they have the same base in case of division also, when you are dealing with division, it's meant to become smaller, so you subtract them. And so you realize that the final answer will be lesser than the very first number in consideration, like that of the multiplication. So let's see another one. Another law says that, if you have something like a to the power of negative x. So this is negative power rule. Negative power rule. This is also easy to understand. This is what I do tell people. You see this negative here, this minus. Take it as 1 over. Just have it in mind that every time you see this negative power, the minus here means 1 over. Now, let's consider that, okay, now this is the expression. I have taken minus out. I've changed the minus to 1 over. So what will I have left if minus is being removed here? I will have a to the power of x here. So that's what you will have. So that's just what the law says. Now, before I proceed, all these letters you see on the board are going to be numbers, actually. So, but you need to first of all understand the laws, so that when you see questions that are related to numbers, you know how to operate and work with them. So that is what I wanted to say. So let's see another law. Another one is this: if you have a to the power of x over y. If you have this, this is what you do. This means this. Now, the power here is fractional. So this law is fractional power rule. So that means an initial expression where the power is fraction. That's what this means. And so, whenever you have this form of question, what you do is, you see this divisor here in the power, the divisor in the power will become like the roots. You put the y, you put it here. The divisor, you put it here. Now, the main letter here, or whatever number it is, you put it inside the root symbol. Now you bracket the whole thing, and then this x, that is the numerator, will be put up here as power. To be represented up here as power. So that is how you approach this. Alright, so this is what this means. Now let's see another one. If you have something of this nature, a raised to power minus x, right? Just like I told you the other time, this minus is what you are considering first. So if, like I told you, I said this minus, let it turn 1 over. Now, if you have to cover that minus, out of what you have, when you remove the minus has changed to 1 over. You will be left with a to the power of x over y. So now, you will realize that this denominator is just the same thing as this one. So because of that, this 1 over, I'll still have it 1 over. Now this thing, this expression, this denominator looks like this one. So I'll just make this one obey this same rule. The y will become the roots. The a will be in the roots. And the entire power, which is x. The numerator will become the power, which is x. So that's another law of indices. This is another law of indices. So we need to really understand it. Alright, so another one is this. If you have, okay, I think this will be easier. If you have a to the power of 1 over x. A to the power of 1 over x simply means just with the same idea of this. The same idea of this. So it simply means the x is the denominator, you make it the root. And you put your a in the root. Now, you have raised to power 1. And anything raised to power 1 is just that thing. So you don't need to put the 1. So that's what this is. So we are going to apply all these laws to questions soon. We'll apply them to questions to see how to go about them.